Hey guys, Josh Bottum here from Southlake, Texas. Glad to be here supporting the community. Hopefully you can see a couple slides I want to put up and then do a quick demo on Kubeflow. Can you guys see the first intro slide?
Yes. Yes.
So hi, I'm Josh Bottum. I'm based out of Southlake, Texas. I'm a Kubeflow Community Product Manager. I've been a product manager in Kubeflow since Kubeflow 0.5. And Kubeflow, we've had the same mission statement for the last 3 years. So Kubeflow now is 3 years old. David Aronchek from Microsoft likes to say this is the same statement we've had, and it's very hard to do, so we keep it. But we want to make it easy for everyone to develop, deploy, and manage a portable, composable, and distributed machine learning on Kubernetes. So that's a lot of words, but if you think about it in real life, you know, if you're developing machine learning models, often you're either doing it on your laptop or maybe on-prem in public cloud. And you need to support a lot of different types of frameworks. Maybe you're doing TensorFlow or PyTorch or Keras or scikit-learn, maybe even XGBoost to provide image classification or regression or lots of different types of solutions that people are looking for. And Kubeflow helps you to build, train, tune, and deploy a machine learning model. And it does this with Kubernetes, so it provides you that capability to leverage distributed compute with a variety of either CPU or GPU, and then also use auto scaling and node placement. So all that together gives you that delivery of operational and infrastructure efficiencies on Kubernetes. So as an open source project, this is a very complex stack that solves a very advanced problem. In Kubeflow, we just released Kubeflow release 1.2. This is our 10th release over the last 3 years. So we have a release about every quarter. We went application complete in November 20th, almost the last day of KubeCon. In a process standpoint, from a community, we've done some work to have each of the separate components of Kubeflow be able to define their roadmaps, whether it's the training operator or the hyperparameter tuner Katib or some of the other tools, the pipelines. And we've also defined a versioning policy that defines whether an application or a component is stable, beta, or alpha. And then we've also had these application requirements that are a template for what it means to be stable. We track the deliveries in Kanban boards as well as issues. And when we're done, we have a change log and a release announcement. And you can see down here all of the stable components that Kubeflow now has delivered into 1.2. I know this is a bunch of words down here. You'll see in the demo how this comes to life in a few minutes. Machine learning is an advanced and complicated environment. And if you look at this pictorial here, you'll see that there's a workflow to deliver a machine learning model into production. And probably the difference between just regular code is that with machine learning, you also have to bring your data along. So you have your code and your data, and you may have your data scientists working on your ML code, and they're working out of an IDE like a notebook, and then they'll train their model. So they'll train the parameters inside the model to be able to predict the right answer. And then they'll tune that model with a hyperparameter tuner for all the parameters outside of the model itself. They may double check that with an auto ML tool that will make sure that if I'm using TensorFlow, maybe PyTorch is better. They can do some model analysis and look at the data sets pictorially or visually, as well as their code. And then they'll often develop pipelines. So one of the most important things about developing machine learning is the fact that you're not just doing it once. You continue to rebuild this pipeline as new code or new data comes in. And so while you're doing all this with your code, you're also bringing in data at the same time and running it through you're labeling that data. So now you can use it in test sets, in training sets. And then you also have a feature store so you can more easily start from a place that you've already done some training on and leverage and not have to continue to retrain on data sets that you already know the answer to. But anyway, as you're bringing these along, these two workflows, you bring them into the pipelines. You have an artifact store that's capturing all the artifacts, all the data, all the code, all the metadata and dependencies necessarily along the way. And then once you have all that done, you need to then put it into production. And usually the people involved in this is an ML engineer, and in the pipeline portion, and in the deployment is a DevOps engineer. So you can see there's different phases, there's handoffs from different teams, and there's both code and data. Now what Kubeflow works to do is provide you a composable set of components. You don't have to use them all, but what it's really designed to do is make this workflow easier and make it work end to end and really go through those components that we've talked about and have all that run on Kubernetes, right? So you get that auto scaling, node placement, a very efficient infrastructure, as well as operational efficiencies that Kubernetes delivers. But one of the things that you'll find is that we have worked with folks in the Kubernetes in the Kubeflow environment for about the last 4 years, and we start to see these gaps come up, right? So there's a portability gap. When people need to deploy Kubeflow on their laptop and on-prem and in AWS or in a public cloud, it doesn't always deploy exactly the same. So you need some form of process, typically a GitOps process, to make that work better. There's an automation gap. So the data scientists in some of these workflows have to build Docker containers or know kubectl commands. And lots of times they just want to work in the notebook. And so there's work to make this automation easier. And then there's a reproducibility gap. So as you're going across that workflow, you want to be able to snapshot your complete environment, right? So the complete environment being the code, the data, as well as the metadata and the dependencies. And you want to do that in a programmable way. And then the last piece is a security gap. The open source version leaves people open to say, how do I access external databases perhaps from my notebook? And sometimes people may not use best practices like leaving credentials inside of a notebook. So there's best practices here that people need to pay attention to and leverage the Kubernetes native aspects. One of the things that our company does, we're one of the leaders, contributors to Kubeflow, is to surround Kubeflow with a couple of tools to make the life easier. One of them is an open source tool called Kale. And what Kale does is basically help from your notebook to build this pipeline without having to go and have the data scientist manually build Docker containers to do training or hyperparameter tuning, or even now into model deployment. So what that means is the data scientists can do more of these steps on their own. Now, in addition, there's credentials and secret management that have been incorporated into this stack that allows for auditing and compliance, as well as just better secret management. All that is running on top of the Kubernetes and the Kubernetes CSI, and then leveraged in with a scalable standards-based storage class. Using CSI, you can have a storage class, a snapshot store that is taking snapshots along the way that allows you to share your data or your complete data science environment across clouds, as well as provide the lineage to see where everything came from as you walk across these steps, providing that versioning that you need. So now I'll just go to a quick demo. This is the demo that we provided with Google at KubeCon. I'm going to do the 45 or 50-minute demo in about 7 minutes, so you're only going to get part of it. But we're going to show building a model, and then we're going to build a pipeline that trains that model. We'll tune the model. We'll do the hyperparameter tuning. We'll deploy and then monitor the model. And all of this you can run with a very easy way on AWS and GCP and their marketplaces. I'll show that, as well as the tutorial and the KubeCon workshop information. All those links work that can drive you through. MiniKF is mini Kubeflow. It's available both on GCP and on AWS, and it's very easy to set up. I'm just kind of showing you the click through that you go through. You go on to AWS Marketplace and you can find MiniKF, and you'll have, like, for example, all your tutorials are right here. And then you can just click through to provision this 40 node cluster and get it up and running. You just basically take the terms and conditions, almost all the defaults that you would have, you would keep, like the delivery method, the storage version, the region. You may pick something closer, right? Because you want to minimize your latency. You go one more click, and now you're into the last part of provisioning this. We'll go through 5 different things. You just use the defaults, choose to launch from website, EC2 instance, the VPC, and the S subnet. If you want to change those, you can, but you don't have to. The only thing you really have to provision is this right here, which is you have to create a security group and then put in your key pair. You hit launch, and in a few minutes, you'll get a screen basically that looks like this, which is a login screen to get into your Kubeflow. Now, this is integrated, or you can integrate it with your single sign-on via Istio and Dext. So that is at the Kubernetes layer, and then you have an OIDC capability to run into your AD or your Active Directory or your LDAP. But you can put in your username and your password, and what that does is allow you to get to the central dashboard, and it also maps you into a Kubernetes namespace that allows you to have isolation either for a team of users or a single user inside that namespace. So that gives you some good security from an environment, an enterprise standpoint. This is the Kubernetes or the Kubeflow central dashboard. You can see you've got your quick shortcuts, your recent notebooks, documentation, and pipelines. We're going to go in and start to investigate some of these components here. The notebooks, you can see there's volume manager. So we were talking about persistent volumes earlier. This shows you all the persistent volumes that you have running, and you can move files in and out of those persistent volumes very easily. All the models you're running, your snapshot store, all your pipelines that you've created, your hyperparameter tuners, and all your artifacts. In the interest of time, I'm going to get into the demonstration. I'm going to go right into a Jupyter notebook. This Jupyter notebook is a machine learning model. You probably may not be able to read this, but this is a Kaggle competition to build a vaccine for COVID-19. And basically what the model intends to do is to find the places, to find the molecule or the bases, I guess these branches are called bases, that won't break, right? That are safe from degradation. So if you're going to build a vaccine, you want to build it off of this base rather than one that's prone to cut, because the cutting ones then will degrade and not be viable as a vaccine. So what they've done is they've already sequenced all these, and they've gone through and they've looked at the places that are prone to cut. So they have a training set that they've created with 3,000 RNA molecules that we're going to use in training this model that we're going to build. Now, best practices here when you're building a model is first you have to install your packages. You can see that this is installing quite a bit of packages. Your Scikit, your Keras, your TensorFlow. This is a TensorFlow TFX library, TensorBoard, a few other things. Then another best practice is to go through your imports. So you bring in your NumPy, your pandas, and then another piece is to put your hyperparameters all in one place. These are parameters that affect your model, but aren't in the model itself. And we'll talk about that a little bit more. Next is we'll go through 4 more steps, which is just loading your data into the model and then pre-processing this model. This is basically taking the representations of the sequences that are in letters and in characters and turning those into numbers. You do that via a tokenizer that has a dictionary. Once you've done that, then you train the model. So you run it through some code that says, okay, now I'm finding the places that are safe from degradation. And then you train the model on a data set that you know the answers to, and you continually improve the coefficient of the linear algebra equations in order to make sure that as you run through that equation, you're getting a model that predicts which one is actually going to show what that base is going to do. Is it going to cut? Is it going to break apart? Or is it going to be safe for degradation? And then after that, we'll evaluate the model with data that the model has never seen and make sure that it actually can predict well. And then we'll submit this to the Kaggle competition. Now, I went through that. It's pretty long, but what we really want to be able to get to is not just to do this once, but to do it multiple times. So we want to build a pipeline that goes through these steps that I just talked about. And that's what Kale does. Kale is an open source tool that's an extension to notebooks. And what it allows you to do is to tag cells within the notebook that will become pipeline steps. Each of these steps are Docker containers. So you basically come in and you say, this is a pipeline step. I want to call it load data. You give it a name, an arbitrary name, what it depends upon. This is the first step. So it doesn't, and whether it needs a GPU or not. You can see that this is very easy for a data scientist to do, rather than if otherwise he would have to take all this code right here, put it into a Docker container, put that into a repo, and then use that in a pipeline. The second step in his pipeline would be data pre-processing. And you can see here, this is again a pipeline step, very easily to identify it. You give it an arbitrary name, data pre-process, and you pick which step you want it to be dependent upon. In this case, load data. Now, in order to build my pipeline, I just hit this compile and run. It will then validate my notebook. It will snapshot it so I can reproduce this. I have a version of it, and then upload the pipeline. And in a few minutes, I will get a pipeline that looks like this direct acyclic graph. And as I said before, this shows how all the data is flowing and also the sequential processing of that model that we just built, right? And this is now in a pipeline that is reproducible. So if I do come up with new data or new code, it's very easy to run it through this process again. Now, each of these steps are snapshotted, and I can go in and investigate and alter any of these steps, and then rerun this process again in case I've made a bug. Now, the other piece about this is once I have my model working pretty well, there are parameters outside of the model that need to be tuned. These are called hyperparameters. So the hyperparameters are now you have the ability to tune them right from the notebook itself. This is like the learning rate, the batch size, the embedded, the dropouts, the sequence, the epochs. And then what this does is automatically figures out the right set of parameters to make your model run both efficiently and most accurately. So you can pick a search algorithm about how to pick those parameters. You keep one parameter constant, you move it up and down, and then you see if it gets better. If it does, you move in that direction, and then you work on the next parameter. And you're going to try to do this to minimize validation loss. So if I went and I go and run this cat tib job, again, it's going to snapshot my environment, compile it, and then run it. And I will start to see a graph that looks like this. This is a new UI that has come out. It's coming out in Kubeflow that allows you to tune your model very quickly. And what that means is typically I would run a bunch of different of those pipelines by adjusting all these parameters, this dropout, this dim, this batch size, the learning rate, in order to find the best validation loss, right? And I'm going to run, like in this case, I set this up only to run six pipelines, but you could run 20 of these and each of them could take an hour to run. Now, this tool automatically runs all those for you and highlights the best one. So what we've done so far is we've made a machine learning model. We've made, then from that model, we've made a pipeline. Then from that pipeline, we've been able to run through a hyperparameter tuner and we've tuned the hyperparameters. Now we want to put this into production. So to put it into production, we can click on this and it will show the actual pipeline that we had that actually delivered that model. And then we can dive into any of these steps, but really we want to go into model validation and look at the environment that was snapshotted basically programmatically. And then if we click on this button here, it will bring us to this snapshot store that has now captured the complete environment, data science environment at that step. All we have to do is click on that URL, and that enables us to take that environment and build a new notebook, which we can now serve our model from. We can call this serving model. And all we have to do is paste this in here, and it automatically fills all the parameters in to make our notebook. So it brings the proper custom image. It brings all the CPU and RAM settings that we need. It brings the workspace and the data volumes and all the dependencies that I need, all the configuration, everything I need. I hit launch and it brings up that model basically in a new notebook. Now, I want to serve that model, which means I want to actually send data to it and have predictions come out. In order to do that, we've simplified that process to this step that I'm showing. Typically, you would have to build Docker containers and write a custom resource definition in order to run this. Instead, what you have is these 5 commands that are at the end of this notebook. The first one is this kale command that brings in the serving utilities that allows us to be able to serve a model directly from the notebook using Kubeflow serving. Then this command right here packages the model appropriately, snapshots it, and then starts that serving process, which basically starts 2 containers, one with a transformer and one with a predictor. The transformer will take the data that comes in and transforms it and then sends it to the predictor, and the prediction will start to make predictions. So all these commands here, this is an interactive Jupyter notebook, so you can see that it's running through all the commands to actually put out the inference server. We've done that. Now, in order to send data, I prepare the data with this data statement here. I also have this new KF server command, which allows me to monitor my model, which we'll see in a second. And now by running this command right here, which is associated with my data set, I can actually see this model start to go and send data to it and bring predictions back. And over on my my monitoring, I can see my logs starting to log the data as it's being processed through the transformer. This is the log of the predictor. And then also, you'll see this start to spike up. This is a set of metrics that are now available directly to the data scientist from the notebook, where he can see now his CPU utilization, both for his predictor and his transformer, start to spike up, and see how the memory and all the different components of this are coming together. There's much more to this tutorial. In the interest of time and keeping this in 30 minutes, I'm going to just go back to say, look, you can go through this tutorial. It takes about 45 minutes to run through, but at the end of it, you'll learn a bit about how to run through, and all these are clickable links. They're easily to run in both AWS and GCP, and the tutorial is step-by-step. I think I showed it before. Kubeflow 1.3 is next. This is a release that will come in March of 2021. We're at the feature definition. All the working groups are now engaged. The notebooks, the hyperparameter tuner that you guys saw called CATIB, the pipelines, we showed that. KF serving, you saw serving a model. Training operators, those are for distributed training. When you run your training jobs across multiple nodes, you saw some training in this, and your manifests that use GitOps and customize for deploy. All those groups are working. My company, Arrikto, is actually the release manager for Kubeflow 1.3. We're doing, AWS has been kind enough to provide the test infrastructure for this. So you've seen kind of a movement away from GCP. If you want to learn about deploying multi-node Kubeflow clusters, this manifest charter and working group notes is a place to start, and you can join into those meetings. Getting involved in Kubeflow, right? There's a Slack channel, there's a website, there's a discuss mailing list, and we have weekly meetings. Definitely invite people to come. We get so many interesting projects that we work on that you'll just have a lot of fun. And if you're looking to upskill over the next holiday, this is a place where I think you can have a lot of fun, meet a lot of people, and potentially get some good personal feedback. So that's what I had. Hopefully it was helpful.